Private Limited as senior engineer, having a role, uh, having the responsibility of developing or designing architecture for one of the machine which is used to harvest the grass, which is used to feed the cattle in uh, um, in Northern America. From the educational background, I done my masters in electronics design and technology from uh, institute in Aurangabad, which is under the Ministry of Information and Technology. The institute is called as a DOEACC, which is in the university, which is under the campus of University of Aurangabad. Then I done my bachelor's in electronics and telecommunication from DY Patil College, Akurdi, Pune. And earlier that I completed my diploma from Government Polytechnic Aurangabad. From family background, I am natively from Ahmednagar and currently living in Pune with my wife and 2 years daughter. From hobbies and interest side, I love reading and trekking. Okay, so we'll start with our fundamental uh, point is what is robot. Okay, so it is a electromechanical device. Okay, that perform different types of tasks, different types of operations, uh, and it interact with the environment with or without the human interaction. Means some of the robots needs the manual uh, inputs from the human. Some of the robots are capable of doing its part without the inputs from the human. Any input from the human, it takes the decision uh, uh, on its and do its task. So two classic examples of robot I mentioned in the pictures. The left hand side is our Chandrayaan uh, Chandrayaan Land Rover, which the ISRO sent to the moon, and the second classic picture is from the Mars Land Rover, which sent by the NASA. So these are the very highly and complex design of the robot, which includes so many input devices, so many uh, output devices, the complex logic of complex algorithm which perform this task and works autonomously. Means it does not require the human interaction. It do its work on its own and send the information from you can imagine the from Mars or from the moon, how complex it is. So we do not go in that complexity. We'll see the simple design of simple part of the robot subsystem. But you can imagine how the robots are nowadays, the complex and doing how complex operations and tasks. Okay, the robotics. So this is the robot. Then what is robotics? So robotics is a science and technology behind designing, manufacturing, assembling of these robots. Okay, so how robots are classified? Okay, so robots are classified by these different criterias, like application, then what are the actuation systems it used, what are the control methods it has, what are the programming methods it is used. So if we see The application classification of the robots, like the welding robots, which is used on assembly line in the industries, where these robots are doing the weldings. Then the assembly robots, the if you go and visit any automotive plant, or any uh, car plant, where the assembly is nowadays doing uh, by these robots. It is very efficient, and these they do their work very efficiently, very fastly, so that the production is increased. So like the application, the robots can be classified. Then mm, another criteria for the classification is the actuation system used by the robot, like the pneumatic, hydraulic and electric are three most used actuation systems in a robot. Like in pneumatic, it is used the air pressure to actuate or to do the motion or the task, output task, which that robot is intended to do. Then the hydraulic is some liquid is used to control the movement, or the electric. By the electric means the electric motors or electric actuators is used. So pneumatic actuation system is mainly used on a very uh, uh, where where we need a low force, or it is necessary, or on the factory floors, where a lot of pressure is not required, because the pneumatic system cannot generate the huge pressure. So where low pressure applications are there, at that application, the pneumatic actuation system is used. The hydraulic applications is mainly used in heavy applications. So if you see in a tractor and their implements, they are used the hydraulic system. So in our machine, on the machine which I am working, we are having the hydraulic actuation system. So the header which is connected to the machine is very heavy duty, and to operate that header, like the operate the header height or operate the other operations of that header, we need a lot of pressure uh, to actuate that system. So that's why we use the hydraulic part. The electric actuation system nowadays very common. I can see, I can say that the now electric motors are used to actuation of the system. If you take a example of a robotic arm, which I here, which I given into the heading slide of the presentation, is this is the robotic arm, and here we use the electric motors like servo motors or stepper motors to control the movement of this arm. So nowadays, this electric actuation system is very much in used, because it is simpler to control, and simpler to control the movement, and very efficient and low maintenance. Okay, then the next classification is by the control method, the servo control or non-servo control. So servo control means it is a closed loop system. We continuously monitoring the output motion, and try to take the input back to the system and try to adjust that movement continuously. That is we called as a closed loop system. In servo and in non servo, it is just a open loop. We just command the actuation system that do this motion, and we depend on the actuation system to do that operation. Then the path control. So you can uh, there is nowadays in colleges we have so many competitions into the uh, so many competition conducted by so many institutions for the robotics, and we can see here there that they have a uh, uh, path control robotics, meant it is following one trajectory defined or programmed to that robot. It follows a one path. That way we can see that it is a path control robot. Then the programming method, the robot also classified by the programming method, that is online programming or the offline programming. So online programming means direct use of the uh, robot, means we do the programming of the robot on the go and use that robot, or the offline programming when we uh, program that robot, and then that robot is doing its operation defined by that program. So if you see on the assembly line of the any of the plant, the robots are already programmed offline, and then that robot is doing its task, like uh, if you want to assemble a door of a car, then it is programmed accordingly before doing the operation. And when we start and when we switch on that robot, then it is performing that assembly, like take the door, place it at the uh, defined position, uh, then screw it or weld it. Like this we can we can classify the robot how we program it. Okay, the next is the applications of a uh, robots, and nowadays the application domains are very vast for robots. Like I said, the factory automation now. In fact, in all the factories, we can see these robots working very efficiently, very much. Uh, the increased productivity of because of these robots, and it is now simplifying the operations, the complex operations by using these robots. In medical domain now, nowadays in medical domain, the use of robots is now increasing, like do the complex surgery, uh, uh, or to uh, I can say to have assist the doctors doctor or nurses into the operation theater. So many robots are now doing the work they in medical domain. In hospitality domain, by means in the hotels, nowadays due to this COVID-19 situation, uh, uh, the hospitality domain is very much affected. So nobody is visiting the outside world, everybody is locked down, and due to the fear of the infection of the COVID-19, and at that places now, uh, so many robots are doing the services into the hotels, or doing different kind of operations in complete hoteling system, and that's where the application of the robot is now increasing. In aerospace domain, so in aerospace domain there is lot of complex systems are involved, and to test that system, nowadays robots are very much useful. In agricultural domain, I can say, uh, uh, we in India, we are still behind the use of these robots. We have started in some part of the India, but not very aggressively. There is lot of scope to use these robots in the agricultural domain, and we can have very much opportunities in agricultural domain. In hobbies and competitions, like nowadays, so many uh, enthusiastic uh, people are increasing the hobbies into the robots, and they are trying some simple systems of robot, like uh, pathfinder robot, or say, you can say, nowadays in Aurangabad, uh, one of the engineering student is invented a robot which is helping doctors and nurses into their uh, uh, into their servicing the patients. So this is how the applications are. uh, so many applications we have for the robots, and in military applications, you can see, to find out the mines, uh, and explode them. Nowadays in defense domain, the robots use of increasing, as there is so many uh, sit- situations where the human life is at stake. At that places, nowadays the defense system is also using the robots. One example which I shared is finding out the mines uh, which are uh, planted by the enemy. There we can use these robots to find out those mines and dispose them. Okay, now we'll see how the robot subsystem is looks like. This is the simple block diagram of the robot system, where we are having a input processing block. This input and the input processing blocks takes the inputs from various inputs, like a switch. A simple switch can be an input. So if you want to we will take the example of robotic arm. So if we want to perform a motion of lifting our robotic arm, so we'll just press the button, and that button gives input to the input processing, and the motor activate on that input, and our robotic arm get lifted. So that's the way that uh, simple switch can be also input processing, or another input can be from the sensor. Our different types of sensor, like temperature sensor, humidity sensors, or proximity sensors. So different kind of sensors we have, that can be also a input to the input processing unit. So input processing unit then op- process the input provided by any sensor, any part of the input. Then it process and it feeds to the control logic. So control logic then do the sequential operation on that. It decodes that input, what that input means. It decides on that part, and take a action whether to actuate our actuator or not. So control logic gives output to the actuation component, that now if we have a simple electric motor, then it just give power to the electric motor, and electric motor starts rotating. So to drive that electric motor, the actuation components do a very important role. The actuation component provides the uh, inputs to the electric motors, like what is its current rating, what is its voltage rating, and how much voltage we need to feed, how much current we need to feed to the actuation component. That decides by this actuation component. So control logic just gives the command on, and then the actuation component see that command, that the control logic is given. And if it sees the on command, then it starts providing the current to its actuation. Or in case of hydraulic or pneumatic, it starts increasing or decreasing the pressure into our hydraulic subsystem. So this control logic resides in a controller, and that controllers continuously executing the commands which feed by the programmer. Okay, then next slide is I have given different view of the similar system. Here we just have a single flow, like from the input processing to the control logic, then to the actuation component, and then our actuators start its motion. This is called as an open loop subsystem, where we do not get any feedback from our actuator, and we sim- we simply depend on our actuator to perform its operation. This subsystem is called as a closed loop system, where we are taking uh, taking input from giving the feedback from the actuation system back to the sensing component, and we are continuously monitoring the operation or motion of our actuator, and we'll continuously control that. So it is from this open loop subsystem is not that much efficient, but it is very much simple. So when we go into the closed loop subsystem, it is the complexity is increasing now, because we are continuously monitoring our the output motion and try to control it. So the right type subsystem is the mechanism plus the environment. The mechanism means the sensors or actuators, or and the other environment, outside environment of that. We continuously monitor the outside environment also, and our output motion also, and we are by using different types of sensors, and that sensing information we are feeding to the controller. So in controller, you can see there are different blocks there. The sensing model is the first block, where we take the input from the sensor and process that input. Then sensing model gives output to the regulator, and regulator then takes the decision uh, how we want to regulate our actuation output, and it gives a command to the actuation model, and then actuation model again drives our actuators. Besides that, we are having another blocks into the controller, like the system model and the planning. The system model and planning and the regulator model interacts with each other to and flow, as the arrows suggested. it is the communication between these models are two-way communication, means regulator is communicating to the system model and system model is communicating to the regulator. Same way with the planning. So these planning and system model doing having the algorithms like how much is our motion. If we want to uh, rotate our motor say by 20%, then system model continuously check whether we have reached to the 20% of rotation or not. And the planning model do the planning, how much is the remaining percent. Suppose now the motor is moved to the 10%. Now planning model says that now the 10% is still remain, 10 degrees is still remaining. We want to again give command to rotate our motor 10-degree. So the planning model is doing that operation. Then the next is, now we'll see these sensors, actuator component, control logic somewhat in detail, by what is the sensor and that. So sensors, if you go by a simple definition, it converts a physical parameter into the electric parameter, or it is uh, just a conversion of energy from one form to another form. Okay, so simple example of sensor is a mercury uh, in the glass of the thermometer. So you all seen the thermometer available with the doctors to check the temperature of our bodies. Yeah, I think s- s- we have questions. Let me see. Can we have questions right now, or is
No,
it
sir.
okay if we...
We will have question answering session at the end of your presentation.
Okay, okay, okay. I saw the participant raise their hand, so I thought that there might be some questions. So we'll take your questions, participants, at the end of session. We are having a 15-minute slot for question and answering. So note down your questions, and we'll take those questions at the end of session. Uh, so in thermometer, that mercury, when that thermometers gets in contact of the human body, uh, the mercury then expands by the heat of our body, and it it expands and rise into uh, the glass tube. The glass tube is calibrated such that it is giving us the reading in the form of temperature, either in degree Celsius or in Fahrenheit. That depends on the what is the calibration of that glass tube. So this is the simple example, day-to-day example of the sensors which we all came across. Okay, then how to choose a sensor for our applications. So there are different kind of criteria we have to choose a sensor, uh, and it depends on the accuracy of the sensors, means how much accurately uh, uh, we want to sense our in case of temperature, how much accuracy we want. Means if you want to measure 1 degree Celsius temperature, how much percentage means if you have a accuracy of 1%, then we can see a tolerance. If our reading is showing 1 degree Celsius, it might be 0.99% or 1.1%. So this is mean by the accuracy, how much accurate system we want. Then it also depends on the environment conditions, and usually has the limits for temperature, humidity, and other environment parameters like radiations. So many environment conditions we need to take into consideration while selecting a sensor for our operation. Then the range of that sensor means, if it is a temperature sensor, then whether it is detecting temperature from 0 degree Celsius to 125 degree Celsius or minus 40 degrees to 120 or 100 degrees Celsius. So depending on these different ranges we want to, so if we want to use our system in Siachen, then the temperature of Siachen can go till the minus 50 degree also. So while selecting a sensor, we should check the ranges of the sensor at how much temperature it can sustain and it can operate, and we then we need to choose our sensor for our operation. Then the calibration is one of the criteria. So for most of the systems, the calibration is required, and we need to also check whether how our system is calibrated, how we want to calibrate it, and depending on that we need to select our sensor. So some of the sensors also do not need the calibration, and they are very simple. Like I can take an example of speed sensors. So speed sensors generally do not require a calibration, because this speed sensor is working on the frequency and duty cycle, and it is fixed. So at that much speed you will get that much frequency, and that is the fixed. So we generally don't require the calibration for the resolutions, and depending on your application whether you want calibration to perform or not, we need uh, and on that criteria we need to select our sensor. Then there are other criteria like resolution, cost, and repeatability. Resolutions means the smallest increment which we want to detect by the sensors. So suppose our sensor is capable of detecting the speed. If you take example of the speed sensor, it is able to detect a change of 1 kilometer per hour, and you are having an application where you want to sense a speed by zero point 0.5. We want a resolution of zero point 0.5 kilometer per hour. Then you cannot use the sensor which is having a resolution of 1 kilometer per hour. You need to select a sensors like select a speed sensor which can detect a change of zero point 0.5 kilometer per hour. Then and then only you can use that sensor for your application. Then cost is one of the criteria. You want your sensor uh, cost effective, uh, as this cost is getting added in your overall system. Then the repeatability is called the reading that varies is repeatedly measured under the same environment. Means your other environment criteria, other environment is remaining the same, and You want a reading, repeat you want to take a reading repeatedly to take the decisions on that, like the temperature. You in a furnace, uh, uh, in a molding furnace, if you go, we want a specific temperature to melt our metal, and we want to repeatedly measure that temperature in furnace environment. In furnace environment, the other criterias, other environment parameters remain the same, just the temperature is increasing, and we want to repeatedly sense that temperatures and average it out. So that is another criteria which we can say affect our selection of the sensor. Okay, the sensors are classified uh, by the primary. Uh, then we will see the classification of the sensors. So sensors are classified by the primary unit, uh, which it want to measure, means whether it is a temperature or whether it is a speed, whether it is a humidity, and other measurement, or whether it is a voice. So we can classify the sensors on these measure and type. Then the transduction principle. So transduction principle is the fundamental criteria which are followed for an efficient approach. Means transduction principle means resistive sensor or a capacitive sensor. Will go in detail of this classification of sensors in tomorrow morning, where we see mm, detail in detail of these sensors. Then we can classify our sensors on material, technology, property, the on and the application side. Okay, then the actuators. So actuators is, by definition, if you go, an actuator is a part of a device or machine that helps it to achieve physical movements by converting energy, often from electrical, air, or hydraulic, into mechanical force. So sensor is converting the physical parameter into the electrical parameter. Actuator is converting electrical energy into the mechanical energy, uh, by the means of electric, air, or hydraulic. So these are the, as we see, these are the main types of the actuators which we used in our operation. There are two basic motions of the actuators, either linear or rotary. Linear means it is extending and retracting only in one single direction, and rotary means you can take example of electric motor, where it is rotating uh, around its axis. uh, on these basic motions, we have different types of actuators. So the types are defined by the motion and which power we used, like electric, air, or hydraulic. So in electrical we have two types, linear and rotary. Same with the hydraulic also, will have the linear motion or the rotary motion. And there are one type of different type of actuators, like the linear chain actuators. So with the help of chain, we achieve our motion into the linear direction, to lift a heavy, if uh, lift a heavy machine. You can see that we have a pulley with the chains, where we pull a chain and it's rotates around it, and we'll get the linear action of lifting our machine. So that kind of actuators are also there. Then we'll go to the robot controllers. So it is a processing sensor component. uh, it processes the sensor component output and gives command to the actuator component for any movement adjustment. It is a device which takes one or more inputs and adjusts it outputs. So a connected device function in a controlled manner. So we want action in control manner, then these robot controllers are very much required. Different actuators require different control methods to achieve the stable outputs that we seen that uh, if we want to control the movement of the robotic arm, we need different types of control method, like the servo control method or non servo control method, or the path control. Which type of control method we want, uh, we want to select our controller appropriately. And to perform our final operation, it is very much important that we'll choose our robotic controller very wisely. Then algorithms and software. So the algorithms are a procedure or formula for solving any problem. uh, this is the simple definition of the algorithm. It is a procedure to solve a problem which is based on a sequence of say specified actions. So to perform any operation, so suppose we want to book a Ola cab for us. So there is a procedure to a simple procedure is there to book a Ola cab. So we want to first open our app, then select our source, select our destination, then select the which car you want, and then you select. If you press the book button, it is booking. It books a car for you for that between that source and destination which you provide. So this all sequence is called the algorithm. Okay. And these algorithms are resides inside the controller, where it performs those operations sequentially and give us the appropriate output in the form. In robot, it is in the form of the motion. So different programming languages are used to create these algorithms, like C, embedded C, C++, JavaScript. So there are so many languages currently available to develop your algorithms into the softwares and perform the operation you want. So we can take a question answer session now.
Yes, sir. The participants are requested to put their question in the chat box so we can ask the questions.
Okay. The classification of robots were already covered in yesterday's class. Okay, we have one question which by Mahesh, which programming language is mostly used? Uh, in controllers, mostly the embedded C is used because if you have a controller, mm, with very limited memories, and we want to accommodate our algorithm in that uh, specified memory only. So the most commonly used is the embedded C. How There is one more question, how to design sensors for agriculture. So we don't need to design any sensors. So many sensors are available into the markets, and as I said, as per our application and the different criteria, we need to choose that sensor as per our application. So no need to design a sensors because it is not desired to design sensors if we have so many sensors in the market, and tomorrow we'll see the different types of sensors available and how it is used in the agricultural part.
So the next question is how to control the environment for the agriculture field
Yes,
in case of greenhouses.
yes. So here in this subsystem, if you see the environment in greenhouses is mostly required two types of control, that is temperature control and light control, and then the uh, flow of water that we need to control. So we need to choose first the sensor for application, like by on this criteria, what is the temperature range we want to select, what are the operations, and at the actuation side, either we need a heater if there is if the temperature decreased below our criteria, we need to heat the environment. So we need either a heater, or we need a air conditioner where we our temperature rises from our threshold level, and we want to take it back down uh, to our limit range. So the temperature sensor is most important in a polyhouse. Then light sensors is very important to control the lights or the flow of the water in our polyhouse. So flow control mechanism or flow control sensor we used, and then we need to have a algorithm for that to limit and the actuation system like heater or a valve to control the flow of the water. Like this we can design a system for the polyhouse.
Okay, okay, sir. The next question is how to decide the actuator to be used for different application.
The actuator decides on it is basically on our applications. So like as I said, in the application of polyhouse, we need a temperature to be controlled. So if the temperature goes below, we need a heater actuation, like right. So we need to increase the temperature in a greenhouse environment, or we need to if temperature is so high in the uh, polyhouse, then we need to cool down that polyhouse. So on this on our application, we must select our actuation system. So this selection is mainly depend on the application which we want to perform. So the sensor or the actuators or the controllers, the selection of all these components are depending on our application. It drives mostly in our application.
Okay, sir. The next question is the what is the minimum time lag between the scene or between a command and output? Hello.
Yeah, it depends on so many criterias. The speed of your controllers, at which speed you are operating your controllers, or in the hydraulic, which actuator you use. Suppose you used hydraulic actuator, then the hydraulic actuators are very slow to react. It generally takes 2 to 3 seconds to react onto the given command. But if you use the electrical actuation, then electrical actuators are very much fast to react on your command. So it generally takes around only 150 to 100 milliseconds to perform your operation. And this lag now is mainly decides by which actuators you will use. So hydraulics or pneumatic systems are slow to operate. Electrical systems, electrical actuators are fast to operate, fast to react on your command.
Okay. Thank you, sir. The next question is there is any sensor for detecting the nutrient in the stock solution or in a plant?
Yes, there are sensors available, and we will see those sensors tomorrow in details. We
Okay,
are
sir.
having one detailed session on the sensors, and we'll see those sensors in tomorrow's session.
Uh, how the sensor's accuracy is measured?
Okay, so sensors accuracy is given by its provider, and we can also check the accuracy of the sensors by using a mechanism called the calibrations, where uh, we have one more one more system there. So we in polyhouse will have a sensor, our sensors implemented, and we'll have a thermometer also, which is which we know that it is our reference now. So accuracy is always measured with the reference. So for that reference we'll have another thermometer planted, and we'll see at the temperature of say 40 degrees Celsius what is the reading of our sensor, our system, and the reference thermometer which we taken. And by this way we are measuring the accuracy of our system, of our sensors. And it is given into the data sheet of the sensor, how much accurate is it, because if it is giving at 40 degrees Celsius, if it is giving reading of 39 degrees Celsius, then we will calculate that accuracy into the percentage, and then we can see this our sensor is 1% accurate or 2% accurate or 0.5% accurate. So how close it is giving the reading with the reference. That's how the accuracy is measured for a sensor.
Okay, sir. Thank you, sir. The next question is what type of controllers are preferred for the designing robot?
There are so many controllers available nowadays, from 8 bit to 32-bit controllers. And the selection criteria is mainly depend uh, on how complex your system is. Suppose you just want to control a temperature and nothing else. So you are only having a one operation to control the temperature into the polyhouse. Then you don't need a very high end controller. You just need a simple 8-bit controller, uh, uh, which can perform your which takes input from your temperature sensors and actuates either a heater or air condition depending on the input temperature. So how many inputs do you have, how many output actuators do you have, and based on that we need to select our controller.
Okay. The next question is, what do we need to understand the algorithm and which type of data we require for that?
Okay, so algorithms are, as I said, it is a procedure, means it is a simple procedure written in our day-to-day language. By that procedure, uh, from that procedure we are developing our software. So algorithms required data like uh, uh, what are the what are the operation you want to perform. Then this data can be either in electrical format, in electrical what is the format of your data, like electrical it is analog voltage or it is a digital signal. Then how many sensors are there. So generally in polyhouse the one sensor is not sufficient. We need to have a series of temperature sensors, so that the data from that series of sensors is coming to your controller, and algorithm requires that data, that all that data to perform its operation. So these all data from all the sensors are required for the algorithm to perform the operation.
Okay, sir. The next question is, which industrial grade controller is used for agribots?
Can you come again, please?
Which industrial grade controller is used for agribots?
uh, I do not have the information on that right now, but I will come back to you uh,
Okay,
by
sir.
going into the grades, because for the grades and that I do not have the more knowledge on the grades currently.
Girish,
Yes, sir.
uh, may I have a few questions read over here? Only a few because
Mm.
already we have a lot of questions, and most of the
Yes, sir. Yes.
questions are on sensors. So
Yes, sir.
those can be answered tomorrow in tomorrow's session. So Sumit, thank you very much for your nice presentation. Uh, it will be more elaborative and explanatory to students or candidates in next session. It will be well explained to you in next session. But there is one question that they want to know any robotics laboratory or institution which are working in India and they can use facilities of those institutions for making projects or collaborating with them like that. If you have some of institutes,
I know the MIT institution in Pune, uh, that is having a very good robotic lab with them. We can use we can ask them to facilitate their labs for us. So their lab is most advanced lab which is nearby us, that I know. The other labs I will gather the information on that other labs, and I will uh, either mail to you or uh, I will mail you by collecting the information.
Okay. Okay, sir.
So one example which is readily in my mind is the MIT Institute in Pune.
Okay, for information of other people, there is one initiative started by IIT Mumbai, that is e-Yantra, and you can participate in those as an institute. You can participate in that initiative, and you will get that laboratory at your end. So this is one.
Yes, there
So
are
Sumit
so
will be
many.
providing us information in next session also, and we can have that information afterwards through email. Uh, so I hope most of the questions related to robotics are solved. Other questions which are, I think, those are IP related, so you will not, because till date, how much work you have done in John Deere, if you can't answer it, I know.
The IP
So that will
related
be very
questions
difficult for
are
you.
very difficult to
So
answer.
those information could not be disclosed. So
Yes,
such questions should be avoided by candidates or participants, please. I hope that the
because industry is very much
presenters
cautious
are
on.
having their own concerns.
Yes, so industry is very
So
much
please,
cautious
Sumit,
on part of the IPs.
Virish, you can
Yes.
read one or two questions if there is specific questions related to that.
No, sir. Most of the questions are covered, sir, related to the sensors and actuators.
So sensors part will covered in detail in
Yes,
tomorrow's
sir.
session.
Yes, sir.
Yeah.
Okay, sir. Can you move to the concluding?
Okay.
Nalode, sir.
Yes. You should now. I think most of the questions are answered, and we are at the end of the session.
Okay.
Yeah.
Uh,
Thank you for giving me an opportunity to present, and the unanswered questions. I will definitely gather the information and mail you information regarding those questions. Thank you, everyone.
Thank you, sir. I am here to give a vote of thanks. I thanks Mr. Sumit Devtare, sir, who has given the very nice presentation on sensors and its application in robotics. He explained a lot of the basic anatomy of robot and how the sensors are used for in robots with its application and details, and also given the uh, question answering session with very effective for the participant for understanding the questions. Thank you, sir, and I also thank you to all participants for attending the session. And our next session is at 4 p.m. So please join the session at 4 p.m. Okay. Thank you, sir.
Thank you.
Okay. Sir, shall I we leave the meeting? Madam.
Yes, yes.
Yes.